In this lesson, we will look at how to solve and how to graph a compound inequality. A compound inequality is just two inequalities that have been joined together. First, let's go over a few basics of compound inequalities. A compound inequality is two simple inequalities joined together by the words and or the word or. Compound inequalities can be solved and the solutions can be graphed. So there's no difference. We can solve and graph a regular inequality. We can solve and graph a compound inequality. The solution to a compound inequality that is joined together by the word and must make both inequality statements true. So, for example, if we have a compound inequality that says x is greater than 4 and x is less than 14, both of those statements must be true. The solution must make both statements true. So, a possible solution would be 6. 6 is greater than 4, and it's also less than 14. That solution makes both statements true. The solution to a compound inequality that is joined together by the word or only has to make one of the inequality statements true. For example, let's look at this compound inequality. X is less than 3 or x is greater than 8. There's no solution that can make both of these inequality statements true. I can't find a number that's greater than 3 and that's also greater than 8. It's not possible. So my solution can only make one part of that statement true. X can either be less than 3 or x can be greater than 8, not both. Now, let's look at how we would graph a compound inequality that has the word and in the middle. We're going to start with our number line, and we're going to put 0 in the middle still to separate our positive and our negative numbers. Then we're going to put on our number line graph both of the numbers involved in the answer. So we have x is greater than 5, so I'm going to put 5 on my graph. And I have x is less than or equal to 12, so I'm going to put that on my graph as well. Now, when it says x is greater than 5, we would put an open circle on 5, and my arrow goes to the right, towards numbers greater than 5. X is less than or equal to 12. We would put a closed circle on 12, and then x is less than 12 would be all the numbers that are to the left of 12. Notice how my arrows point towards each other. This should always be true when I have a compound inequality that is joined with the word and. The answers for x are everything in between 5 and 12, so I'm going to shade that whole space. Notice x can not be 5 because of the open circle, but it can be everything in that green shaded area all the way up to 12 and including 12 because the circle on 12 is filled in. Let's look at 2. Let's go ahead and make our number line graph, putting 0 on there to separate positive and negatives. Let's put -4 on our graph since that's part of our answer, and -20 since that's the other part. Now look at what this says. Y is less than -4. So I want an open circle on -4. Numbers less than -4 are back here to the left. And it says y is greater than -20. So I want an open circle on -20. Numbers that are greater than -20 are pointed back up here to the right towards our positives. Notice the arrows pointed in towards each other. That's what we want on an and inequality. And we're going to shade the space in between our circles, meaning y can be anything between -20 and -4. Finally, example 3. We're going to put 0 on our number line to separate positive and negative numbers. Also, because 0 is part of our answer, then we also want to include 8 on our number line. A is greater than or equal to 0. So we're going to put a filled-in circle with our arrow to the right for greater than. A is less than 8. We want an open circle on 8 and an arrow pointing at numbers less than 8. And then we'll shade in the space between our two circles. A can be anything between 0 and 8, including 0, but not 8. Now, let's say that we need to solve a compound inequality that includes the word "and" in the middle. We are going to solve each individual inequality. So let's start with the first one. 4 is less than 2x plus 10. Let's take away 10 on both sides so that we have negative 6 is less than 2x. Let's divide by 2 on both sides so that we have an answer of negative 3 is less than x. Negative 3 is less than x. And if you prefer to have the x be first, let's go ahead and flip that to x is greater than negative 3. Now, let's go solve the second inequality, the second half of this. Let's take away 5 on both sides so that we're now left with x is less than 4. X is less than 4. Now, once we've solved both inequalities, we're going to graph both of them on the same number line graph. Now, let's put 0, separating our positive and negatives, and then we need to include negative 3 and positive 4 on our graph. Negative 3 and positive 4. Now let's look at what the inequality says. X is greater than negative 3. So we're going to have an open circle on negative 3 and my arrow pointing towards numbers greater than negative 3. And x is also less than 4. So we're going to put an open circle on 4 with our arrow pointing at numbers less than 4. Remember, x has to fit both of these. So if we think x must be greater than negative 3 but less than 4, x can be anything in the shaded space between. Now, let's look at how we graph a compound inequality that has the word "or" in the middle. It says x is greater than 6 or x is less than 1. Remember, on a compound inequality with the word "or", one part of the inequality must be true. So either x must be greater than 6 or x must be less than 1, not both. So let's graph both. X is greater than 6. That means an open circle on 6 and an arrow to the right. Or x might be less than 1. So we have an open circle on 1 and my arrow pointing at numbers less than 1. Notice on a compound inequality that has the word "or" in the middle, instead of my arrows facing in, they now face out. They go in opposite directions of each other. Let's look at example 2. Y is less than negative 5 or y is greater than negative 1. Let's put 0 on our number line. Let's plot negative 1 and negative 5. Y is less than negative 5. That's an open circle on negative 5 and my arrow pointing towards numbers less than negative 5. Y is greater than negative 1. Open circle on negative 1 and an arrow pointing towards numbers greater than negative 1. Again, my arrows point in opposite directions of each other. This will always be true on an inequality with the word "or" in the middle. Y can be one or the other, not both. Example 3. A is greater than or equal to 0, or A is less than negative 7. I'm going to change my graph here a little bit. I'm going to make that negative 7 and put 0 up here. Now let's graph. A is greater than or equal to 0. Let's put a closed circle on 0 showing that A might be 0. And let's point our arrow towards numbers greater than 0. Or A may be less than negative 7. So let's put our open circle on negative 7 and our arrow pointing at numbers less than negative 7. Again, my arrows point in opposite direction. I know I have graphed this OR inequality correctly. Now, let's look at how we solve and graph an OR inequality. Just like we did with our inequalities that have and in the middle, we're going to solve each individual piece of this inequality. So let's begin with the first part. 3x plus 4 is less than 16. Let's take away 4 on both sides so that we have 3x is less than 12. Let's divide by 3 on both sides until we see our answer of x is less than 4. Now let's solve the other side of our inequality. Let's add 13 on both sides so that we have 5x is greater than 25. Let's divide by 5 on both sides till we get our answer of x is greater than 5. Now remember, this is an OR inequality. So either x is less than 4 or x is greater than 5. We can't have both. We can't have a number that's less than 4 and greater than 5, so it's one or the other. Now let's graph our solutions. Let's put 0 on our number line. Let's put 4 and 5. X is less than 4. So we have an open circle on 4 and an arrow pointing towards the left. Or we may have x is greater than 5. So we have an open circle on 5 and our arrow pointing at numbers greater than 5. This is an OR inequality, so our arrows should point in opposite directions. You may help yourself remember that an OR inequality has arrows going on to the left and to the right. Just like if you're rowing a boat, the oars of your boat, one goes out the right side of your boat, one goes out the left side of your boat. An OR inequality is graphed just the same. An OR to the left and an OR to the right. Now, as we bring this video to an end, I have two practice problems here that I would like for you to solve. I want you to solve them. Once you're finished, upload your notes to Seesaw. We will go over both of these examples in class on Friday.